Hi, this is Yushin, Huixun, and Xiangyi's group. Today, we will be presenting about the factors that affect the rate of corrosion. Our group has identified three factors: temperature, pH level, and surface area, which affect the corrosion of limestone. Firstly, I will be sharing about how temperature affects the rate of corrosion in different environments. The Taj Mahal, located in Agra, tend to have hot summers and warm to cool winters. The temperature here averages 25.6 degrees Celsius. Now, I will be presenting some data. At an average temperature of 35 degrees Celsius, June is the hottest month of the year. The lowest average temperatures in the year occur in January when it is around 14.6 degrees Celsius. This shows how temperature can vary about 20.4 degrees Celsius with temperatures averaging at about 25.8 degrees Celsius. This graph shows the highest, lowest, and average temperatures throughout the year. Moving on, the Colosseum, located in Rome, has a hot summer Mediterranean climate where temperatures are relatively low except during summers. The average temperature in Rome is 15.4 degrees Celsius. This shows that the temperature in July averages 24.4 degrees Celsius. In January, the average temperature is 7.7 degrees Celsius. Throughout the years, temperatures can vary about 16.7 degrees Celsius with temperatures averaging about 15.4 degrees Celsius. This graph shows the highest, lowest, and average temperatures throughout the year. This slide shows the conclusion of the different temperatures in the two environments based on the given data. I will now be sharing about the experimental procedures and data on the test for the effect of temperature on the rate of corrosion. These eggshells have been crushed to similar surface areas and 7 grams of eggshell is distributed evenly in each beaker. This was how I created water baths. I either filled the water baths with ice or heated them to reach the desired temperatures. Then, using mole ratio, I calculated that 11.2 grams of vinegar should be added to 7 grams of eggshells in order to balance the equation of the reaction. After adding vinegar to the eggshells, immediately place the 250 ml beakers into the respective water baths. After 10 minutes, remove the 250 ml beakers and weigh them on an electronic weighing scale, recording the change in mass, then put the beakers back into the respective water baths. Repeat the previous step and compare the data collected from the experiments. These are the results I have compiled from the experiments. As we can see, the higher the temperature the mixture of eggshells and vinegar is exposed to, the higher the rate of corrosion, thus proving my thesis. Particles have to have enough energy and must be at the correct orientation to have effective collisions, both of which are not present here. As I increase the temperature from 8 degrees Celsius to 35 degrees Celsius, do take note of how the particles move faster with increase in temperature, and how the rate of successful collisions increase as the movement of particles increase. This is because as the temperature increases, more kinetic energy is supplied to these particles, and the rate of successful collisions between these particles increase as more energy can break the bonds between even more particles, thus resulting in a higher rate of reaction. Therefore, I can conclude that as the temperature increases, so will the rate of corrosion.
I will be sharing about how pH value of acid rain affects the rate of corrosion. India faces an increasing threat from acid rain due to large-scale industrial growth, which have led to acidification of the atmosphere. Here are some data in the year 2000 on the dropping of pH of acid rain in certain parts of India. Next, moving on to Colosseum in Rome, there's a lot of pollution from urbanization and industrialization in Italy, which causes acid rain to form. The data here shows that the acid rain in Rome comprises mostly of sulfur dioxide emissions from electrical utilities. To conclude the information gathered, the pH value of acid rain in India is 4.0, the pH value of typical acid rain. I decided to use that value because acid rain have not arrived in India yet. I decided to use pH 2.75, the pH value of sulfuric acid for Rome, because the acid rain in Rome comprises mostly of sulfur dioxide. Now I will move on to the experimental procedures and data. First, I crushed 3 eggshells that are 7 grams each until they are of similar surface area. Next, I measured the pH value of the vinegar I used, which has a pH value of 2. Next, I diluted and mixed the vinegar to obtain different pH values. Afterwards, I put the eggshells and vinegar mixture in a 5:8 ratio. Finally, I carried out the water displacement gas collection method to find out the rate of reaction. Here are the results of my experiment. This allows me to conclude that the lower the pH value, the faster the rate of corrosion, which proves my thesis. Now, explaining how the concentration of acid affects the rate of a reaction. In a solution of lower pH, the vinegar is more concentrated, so the frequency of effective collisions between the reactants will increase and more product will be formed, thus increasing the rate of a reaction. In a solution of higher pH, the vinegar is not as concentrated as it is diluted with water, so the frequency of effective collisions between reactants is lower as and less product is formed, hence decreasing the rate of a reaction. Lastly, assuming that normal rain has only water, no corrosion will take place as there are no H plus ions to react with the carbonate in calcium carbonate.
Now I will be sharing about how particle size affects the rate of corrosion. Firstly, I will be talking about the surface area of Taj Mahal. Taj Mahal's surface area includes the base, the dome, and the four pillars. The surface area of the Taj Mahal is 1688314080 meter cube, assuming that the four pillars are non-existent. Secondly, the surface area of the Colosseum. The Colosseum may look big, but it does not have a very huge surface area. The surface area of the Colosseum is 1320000 meter cube, without the playing field in the middle, assuming that the Colosseum have not been corroded yet. Comparing the two structures based on their surface area, the Taj Mahal will have a significantly bigger surface area than the Colosseum. Now moving on to the experimental procedures and data. Using the equation, we will conclude that the mass ratio of the eggshell to vinegar is 5:8. Hence, the eggshell mass would be 7.74 grams and the vinegar would be 12.3 grams. One egg will be used for each of the three setups. The first setup will include an egg which is not crushed. The second will be an egg that is crushed by hand, which makes the egg partially crushed, and the third will be an egg that is crushed by a mortar and pestle, which will break the egg to bits and pieces. Then place 12.3 grams of vinegar into each setup and record the mass after 15 minutes, 4 minutes, and 1 minute. After getting all the results, find the average rate of reaction by adding up the decrease in mass over time and dividing values by 3 for all of the setups. The result that we got from the egg is that the egg which is not crushed has a 2.3% rate of reaction. The egg that is crushed by hand has a 8.2% rate of reaction, and the egg that is crushed by a mortar and pestle has a 13.4%. Now I will be explaining how the particle size affects the rate of reaction. Firstly, using only one CaCO3 molecule to represent the eggshell that isn't crushed. With the same amount of time, there will be one carbon dioxide molecule formed. Now, if I break down the particle size, one particle will turn into two particles to increase the surface area. This will represent the completely crushed eggshell. With the same amount of time, there will be two carbon dioxide molecules formed. As the particle size of the solid decreases, the total surface area of which the particle may collide increased. The frequency of collisions between reactants particles increases and the frequency of effective collision increases. This shows that even though both reacted at the same time, the one that has a bigger surface area is able to create more products. In conclusion, the Taj Mahal has a greater surface area than the Colosseum, and it will corrode faster. Since 2 out of the 3 factors shows that the Taj Mahal corrodes faster, we can conclude that the Taj Mahal will corrode faster than the Colosseum.